Good evening, all. Once again, welcome to One Mark Solution. Here, please subscribe, like, and share to all of your friends. Again, we are going for the case 2. That means in the board, you know that it is very important now. These two questions are there in the board. That means from different topics. We are dealing with the electrostatics now. So please, again, I'm telling subscribe, like, and share. So we are going with dielectric polarization. In this case study, we are going for dielectric polarization. Dielectric means all of you know that it is an insulator, purely insulating medium. That means it won't conduct, that means it will only transfer electric charges. Now, dielectric with polar molecules also develops a net dipole moment in an external electric field, but for a different reason. Why we are focusing this means two types of molecules are there, polar and non-polar molecules. In non-polar molecules, no dipole moment is there, but in polar molecules, dipole moment is there. In non-polar molecules, we can say that positive and negative charges is putting together. They are coinciding each other. When we are placing in an external electric field, they will be separating and they are getting a dipole moment. But in the case of non-polar molecules, we can say that already dipole moment is there, but due to random motion, we can say that there is no dipole moment in the absence of the external electric field. Just like when the teacher is coming to the class, what is happening? All will randomly moving. When the teacher steps inside the class, what will happen? The students will be sitting in the same seat and they will be arranging in the same manner. Similarly, here also we can say that in polar molecules, the net dipole moment is zero in the absence of the external electric field. But when we are applying an external electric field, they will be arranging in a line parallel to the direction of the electric field. Thus, they are getting dipole moment. That induced dipole moment, we can call it as induced. Why? Because due to external electric field, due to the influence of the electric field only, they are arranging in that manner. They are acquiring the dipole moment. Now we can say that in the absence of an external electric field, the different permanent dipoles are oriented randomly due to the thermal agitation, that means thermal energy. So the total dipole moment is zero. When an external field is applied, the individual dipole moment tend to align with the direction of the electric field. When summed over all the molecules, there is then a net dipole moment in the direction of the external electric field. This process of inducing the dipole moment under the influence of the external electric field, we can call it as dielectric polarization, or we can say the dielectric is polarized. So polar as well as the non-polar molecules will get polarized under the influence of the external electric field. You can see in this picture, the first left side it is given as external electric field is zero, but that is non-polar molecules. They coincide each other. In the second case, in the right side, you can see that external electric field is applied. What is happening? They will be separated apart. They will be pulled apart and they are getting the dipole moment. In the second case, we can say that polar molecules, they are getting dipole moment. They are randomly oriented. And when the external electric field is applied, they tend to come align in the in the direction of the external electric field. They align themselves in the direction of the external electric field. Thus, they are acquiring dipole moment, induced dipole. We'll call it as induced dipole moment. And this process, again, I'm telling it is a dielectric polarization. And we can say which all factors it depends. The extent of polarization depends on the relative strength of the two factors. The dipole potential energy in the external electric field tending to align the dipoles mutually opposite with the field, and the thermal energy tending to disrupt the alignment. Thermal energy is doing like that, but that is why they are randomly moving. So two factors, mainly two, so many other factors are there, mainly two factors. The first one we can say external electric field, and the second one is thermal agitation. There may be, in addition, the induced dipole moment effect as for non-polar molecules, but generally the alignment effect is more important for polar molecules. We are focusing on polar molecules. This, in either case, that means the two cases, whether polar or non-polar, a dielectric develops a net dipole moment in the presence of, influence of the external electric field. They are acquiring dipole moment. That means induced dipole moment. That process we can call it as, again I'm telling, dielectric polarization. The dipole moment per unit volume, we can call it as polarization. That is the correct definition for polarization. The total dipole moment per unit volume, we can call it as polarization. Now we can go for the question based upon this. The first one, the best definition of polarization is, you can just read it out, the orientation of dipoles in random direction, the electric dipole moment per unit volume, orientation of dipole moments, change in polarity of every dipole. No doubt, that is the second one, the option B. That is the correct answer, electric dipole moment per unit volume. Now we can go for the second question, a small problem. Calculate the polarization vector of the material which has 100 dipoles per unit volume in a volume of 2 units. Here 2 units are there, and the polarization vector, we know that what is polarization? Dipole moment per unit volume. So dipole moment per unit volume is 100. So what is that polarization vector? We can say x divided by 2 is equal to 100. So what is x? We can say 2 into 100. That answer will be 200. Now we can go for the third question, the total polarization of a material. How will you get the total polarization? Either you can take the product or the sum or the orientation or the total dipole moment. The answer, the correct answer we can say, we'll just take the sum of all the types of polarization. That will be the total polarization of the material. Now we can go for the fourth question. Dipoles are created when dielectric is placed in which electric field or magnetic field or vacuum or inert environment? No doubt, we can say it is placed in electric field only. So the correct answer is B, that is electric field. Now we can go for the fifth question. Identify which type of polarization depends on temperature. Depends on temperature, we can say. Electronic, ionic, orientational or interfacial. No doubt, out of this, the correct answer we can say orientational. That is the answer for the type of polarization depends on temperature. We can call it as orientational. Now, thank you for watching this 1 mark solution. Please subscribe, like and share. Thank you once again.